Good morning, everyone. My name is Britt Bond. I run the Southwest region for Vectra. This morning, we're going to be talking about NDR and how to leverage the NDR platform to stop attackers in their tracks before they do any kind of damage to any asset that they may be going after. But before we actually jump in and pass over to Jeff Korab, who is a member of my team that's going to be walking through more technical specifics, tactics, techniques, and procedures around NDR. I want to set the stage for really what we're going to be talking about and actually the why we need NDR and how it really is one of the most effective tools in what I refer to as really at the end of the day cyber warfare. Everyone on this session is very familiar with a lot of the tools that are out there in the market today. We spend an enormous amount of time and money putting these tools in place to actually prevent attacks or stop attackers at the gate or at the wall. The problem is not all of these tools are going to be effective, stopping them from delivering these really nasty payloads. And the unfortunate side is it takes hours, up to weeks, even years to try to track down the really bad attackers that can actually bypass these tools. We've seen over the past 18 months that attackers can get in and they can create back doors and just sit and lie in wait to do their damage. None of these tools are actually going to be able to stop what they're going after. Now, let's look at the real life behind this and really what is going into these types of attacks. It's all about behaviors and what attackers are actually doing, right? These behaviors change all the time, and that's the problem, quite frankly. No one profile is actually going to be the telltale signal for what the next type of attack is going to be. Everyone's probably familiar with SolarWinds and supply chain type attacks, right? If you look at the overall profile of this type of attack, step by step over a very long period of time, this is where the nasty behavior actually occurred and where the payloads were actually delivered over amount of time. I refer to this as simply sleeper cell activity. This is where the nasty stuff happens, and you really can't tell how and when the attack is really going to persist over time to let attackers achieve their goals. More importantly, again, back to the concept that behaviors change over time, it's going to be really, really bad. Now, if you look at the signals that drive the overall battle, the telemetry tells the story. A lot of sources out there like Gartner have pushed over time to actually look at and to figure out how are these attacks taking place? What are the signals that indicate the different types of attacks? This goes back to the same context around the attacks that signals drive the intent and the overall battle over an extended period of time. Any number of these types of behaviors can indicate malicious attack to get to the source of what the bad guys really want to get to. So when you look at NDR, NDR is going to play a critical role in 9 out of the 12 top attack vectors that bad guys are going to use to try to achieve their goals. And it's only getting worse every single day. So again, you've got to take NDR and focus on the telemetry as it changes over time so that you can react very quickly and achieve your goal. Now, one thing I'd like to point out as it applies to NDR is that the modern battlefield is changing over time, right? Everyone is making the shift to the cloud. Everyone assumes that proper security controls are in place where they're going to be safe by shifting these applications to the cloud. The reality is that the modern battlefield is getting more risky by the day. Enter Office 365, or the entire Microsoft 365 suite, and all the main entry points for these SaaS-based applications that provide more avenues of attack for the bad guys to achieve their goals. Again, the risk is increasing every single day. If you look at the kill chain from reconnaissance and pre-access to creating a backdoor into any system, all the way to data exfil and impact, again, the risk is increasing every single day because these attackers are looking for new and better ways to achieve their goals and get to their target to deliver their payload. Now, in today's technical presentation that Jeff is going to take over, I want everybody to think about and focus on what really matters when you apply network detection and response, or NDR technologies, more specifically the vector platform, to go after what really matters: time to detection and detections that matter. The longer an attack takes place, the more time attackers can have to achieve their goals. So you have to be able to look and react very quickly, but also have a shorter time to resolution in order to plug the holes, essentially, that attackers are going to use. You don't want to let them persist over time with the backdoors and avenues or additional attack vectors that they're applying to any system, whether it's cloud-based, hybrid cloud, or on-prem network. And at the end of the day, that really means, what type of tools are you going to use in that fight? Consider them weapons to defend against those attackers. That's what it's all about. You also want to have the ability to go back in time and look at what's taken place. You don't want to just simply replay profiles of attacks that have happened. You want to be able to methodically go step by step. And we're going to show you how we do that today. And last but not least, never stop learning. You want to put yourself in the shoes and the mind of an attacker. That's critically important so that you can take these new tools like network detection and response, or NDR, and go after these attackers, stop them in their tracks before they deploy the payload. Okay, that's it. Those are concepts I just wanted to set the stage for. Now I'm going to pass it over to Jeff Korab, one of our premier security analysts at Vectra, and he's going to show you how we take Vectra's Cognito platform and apply it to defeat attackers in their tracks.
Hello, everyone. Brett, thank you so much for that. I'm going to do a little bit of a quick screen share here. And there you have it. So I'm going to do a mixed mode presentation here, if you will, with a little bit of a PowerPoint explanation, but I will go into a live demo as well. So we will be able to kind of see all of that. All right. Give me 1 second here. I've got all right. Brett, can you see the screen okay?
Yep, I sure can.
All right. All right. Perfect. All right. Sorry about that. The spam callers seem to like the most inoptimal time. All right. So here we go. So what Brett was talking about is really gaining that visibility and understanding what's going on in real time. And part of that is one, being able to see everything from a not just a north-south, but an east-west perspective. And two, being able to do it without that fog of noise that comes along with a lot of the systems, where they literally become, and the biggest issue is they become these alert cannons, is I think my favorite term I've heard. But essentially, we in the SOC have a total budget of time for the day, and the issue with that is if we're spending it on things that are not important, we have spent that time and we're not going to get it back. And there's only so many cycles. We can think about it in agile, methodology, if you wish, and you can basically say, I have so many credits to spend, but the truth is there are only so many hours in the day. And if you end up chasing down something with a large number of them repetitively, you just go into the next day behind, and you will never catch up. So what we look to do with this technology is give that east-west visibility, but to also apply a machine learning capability around it so that we can get to a fairly noiseless environment for you, so that you can spend your cycles where they're valuable. So what I'm going to start off by doing is kind of explaining some of the foundationals of how it works, but I'm also going to kind of pivot into what it looks like. And I've got a live system right behind me here, and we will log into this live system, and we will use it as we go through this. So what we're really looking to do is to define these attacker behaviors, these tactics that attackers use. This is very different from, hey, we saw a bunch of port scans, or we saw something on a threat feed that looks like it could be bad, and so we're going to chase it down. And what we're really looking for is really to say, okay, well, if we take a framework, you can call it the MITRE framework, you can call it the attack kill chain, right? There's this progression of things that attackers really need to do to have a successful breach, right? It's one thing to set up a command and control tunnel. It's another to then exploit that command and control tunnel and do reconnaissance activities, or which you'll then need to do for encryption for ransomware or for exfiltration. So there's these progressions that need to happen. So what we're really looking to do is use that east-west visibility as well as the north-south, and build these detections and then make them durable against the framework, right? So I have this hidden HTTPS tunnel. It is command and control. So now I know the command and control has been established to this particular machine. Does that mean that I need to panic at the SOC and deal with this, or could this partially be a phone home? There's a lot of different possibilities here. But at the same time, is this really where my SOC time is best spent? And because of that, what we really want to do is kind of make these determinations, and then from there, figure out if this is where to invest our time. And the way we do that is by looking at, okay, has this command and control become something more, right? Is that machine doing reconnaissance now? Are we seeing port scans from it? Are we seeing RPC reconnaissance going on? What is going on this machine? And has it had something else from it, right? So we can all agree that a port scan from a machine might seem worrisome, but definitely much, much more so if it already has established a command and control tunnel to it in a previous time period. It might even be a time bomb where we're looking at a command and control that was 2 weeks ago, and now we're starting to see port scans coming from the machine. This is where for us, these behaviors come together inside of our machine learning and really tell us this is where we want to spend our time. This is when something is beginning to progress into more than just what we consider to be low-level activity. And so we look at the network, and we look at the network, and we don't do decrypt. We have no need for decrypt. We're able to look at the network, either at the wire data as it exists unencrypted, or we can even look at encrypted traffic. You've seen HTTPS here through machine learning, and we can look at things like the metronomics of the conversations. And without decrypting it, we can make good determinations as to whether or not this is something nefarious, and even categorizing it without the need for decrypt. And we've done that very specifically so that the product itself would be durable over a custom spun crypto, or as TLS gets more and more no man in the middle, the product will still remain relevant and useful, right? When we take a look at the physical network, we can also take a look at the application network. So when we look at O365, what we're able to do is we're able to look at the API calls as if they were packets, and we can apply our logic and our capabilities, our existing AI and machine learning that looks at these attack coverages, and we can look at some basic stuff like SharePoint exfiltration and other download activity from SharePoint. We can look at external access from Teams, but most critically, e-discoveries are a big exploit. Power Automate, Active Directory modifications, because Azure AD and on-prem AD through Azure AD Sync are very, very tightly coupled. We see people who will be successful either on-prem or in the cloud and then lateral over. And then what we'll see is one of the first things we'll see is these Azure AD operations with federation modifications and OAuths and everything else, where they're then able to essentially set up persistent access in AD, and then bypass things like MFA and trusted IPs. So these are the kinds of things that we will look at the the logs in O365 as if they were an application network that use our existing machine learning. And again, I'll show you what that looks like. But essentially, here's some of this durability that we've really looked to build. So when we talk about 365, I mean, the network itself, an NDR solution is an agentless, signatureless, and decryptionless solution, right? So we don't need to put agents on the desktops. We do not have an agent. We do not need signatures. We don't use signatures. Those are very much after the fact, so they don't really work very well for zero-day or state level sponsored attacks, which is what we're seeing a lot of. The behaviors, however, do very much work very well for these things. We're looking to protect the entire suite of product in the cloud, right? So this is not an email protection tool. This is very much a holistic suite of product. So I'm going to stop with the PowerPoint for a minute, and I'll kind of show. Actually, I'll show one more slide, and then I'll pop in. One of our most persistent things that we're seeing inside of attacks now are e-discovery in O365, where people are using e-discovery to do searches for all kinds of tooling. And this was originally developed as an auditor's tool, but it's found its way into attacker hands pretty quickly as a way to search for everything across the enterprise, especially if you got an admin account, regardless of what it's stored in or what format it's in, with keywords, and then using PowerShell to do which is Power Automate is the equivalent of PowerShell in O365 to then do not only the command and control, but to control the exfiltration as well, right? So you're not actually logging in as a user anymore. You've already installed this Power Automate script and you're done, and it's complete MFA bypass. Right. So kind of with all that, I'll kind of show the interface for a few minutes here. So what we have here is we have this landing dashboard, and this landing dashboard really kind of shows us what's going on in the environment. The most important things you'll see here are kind of velocities: 2 new additions in the last 24 hours, 1 new addition in the last hour. When we go into hosts, we'll get a better view. This will seem populated. This is a demo environment that we show. I have a customer that has about actually a little north of 200,000 IPs under management, active. About 100,000 of them are students, and the BYOD devices, about 100,000 of them belong to the university itself and its entities. And they see about 2 critical devices appear in this quadrant per week is what they see. So once that initial cleanup is done, that's basically the velocity, is about 2 or 3 machines into the high and critical quadrants per week against about 200,000 machines in total. So this is very much a noise reduction tool. So don't let the number of dots articulate otherwise. So what we have here is we have these 2 vectors that we're tracking. So as I said, we're a machine learning AI tool. So on one, we're here on the vertical, we are measuring threat. How threatening is the behavior that we're seeing, if what we believe what we're seeing is what it is, right? So if everything is nefarious, how threatening is that? And then on the other horizontal here, we have certainty. How certain are we that what we are seeing is nefarious, right? So I see an RDP connection. That could be a help desk person creating that RDP. So we're not so certain that that's a nefarious thing. But when we begin to see port scans happening from that same machine, we may become more certain at the same time that it becomes more threatening. And so anything that really breaks that 50-50 marker right here in the middle, once we break that 50-50 marker, that is when we go to a critical system. So when I look down here in low, we'll have these machines that have, so here's Banner, for example. We have a threat intel match, right? In and of itself, that is a 70-60, but the machine as a whole is really marked fairly low because we don't see any cross durability. So it's command and control, but is it anything else? Is it starting to act in a reconnaissance way, or is this just a threat intel match? And we know that we see poison feeds. We know that we see decoys. We know that we see a lot of things that just because it's a threat intel match doesn't mean that it's something that needs immediate attention. And so we've got this down here in low, but in some of the less AI-based tools or these tools that don't do behaviors, this is the kind of thing that can look pretty scary, and you can run down a rabbit hole on it for a half a day. Here we're saying this is the only activity we're seeing, and unless we see something different, we're just going to kind of leave it here. We have a time decay component to this, so things will fall lower and lower as they're not addressed over time, because that becomes considered normal behavior. But then when a new behavior comes in, so for example, if somebody sets up a command and control tunnel for remote access, this will decay over time. But then if that machine, even a month later, starts doing something because it was time bombed, this will come back into validity. And so it will be used to accelerate it forward. So when we take a look at machines here, we'll see hidden tunnels, many hidden tunnels. Again, the quantity of these tunnels doesn't matter so much to us. We care about the progression of the behavior beyond just a hidden tunnel. And so as we start to look at some of these machines that we'll have up here in critical, this is where we'll see hidden tunnels and other things that are progressing beyond singular, right? I'm going to scroll to the quick bottom here, and you'll see we're always tracking this attack phase. This particular machine, you'll see command and control, reconnaissance, and lateral, right? We haven't gotten to exfiltration, and we're up here in critical, 90, 70, which means we've probably done more than we need to do because it would have been addressed when it was in medium or high. But what we saw was this hidden tunnel, right? So I'll pop that open. This hidden tunnel was picked up this is a hidden HTTPS tunnel. So it's a tunnel in a tunnel. This was picked up by a fast Fourier transform, an FFT that we have as an AI algorithm. So even though we can't decrypt it, we do know that this is a hidden tunnel in a tunnel. But what we are doing is we're saying, okay, I don't need to see the ones and zeros. I know that that's a tunnel in tunnel. I know that that's the endpoint. And at this point, we could mark an action through a SOAR utility to do a block on this IP address and end this right here. Or this could be a phone home. So again, just that tunnel in tunnel is going to wind us up in low. We've already kind of shown that. What then really accelerated things was we saw that command and control become reconnaissance, right? So here in reconnaissance, we saw the RPC reconnaissance, right? So here's that progression. We saw here's port 445. So this is an RPC recon against a bunch of machines looking for some targets. And when we saw that, this is when that machine really went into kind of that medium high, right? So we saw this and we saw, okay, I got a tunnel. Now I've got reconnaissance. This is when we talk about behaviors. This is what we're talking about, behaviors. This is the command and control by itself is noise. Reconnaissance by itself is noise. The two together are behavioral, right? And I can show you some other stuff here with stage loaders and things like that. But here's where we see the machine. And again, this is all just wire data. We have the ability to lock the host. We can do it from the console here, or this can be dynamically set when certain thresholds are met. We can lock the user account in AD, again, same thing. And then the other thing is this participating in campaigns, because we're able to visualize the entire network. I'll just pick one of these. We can see this machine here, Piper Desktop, that's the machine we went into. It's got a hidden tunnel, and we can see in common these hidden tunnels, and we can see in common these remote executions. This makes it for us what we call a campaign, which is multiple machines being affected by a single attacker or style of attack that are connected to each other. So we'll see this as a whole, and it really works for rapid remediation, right? So you can go and see other machines that are being affected and how they're being affected. And this isn't, and Piper Desktop is a desktop, and it's here on the prem, but this isn't just for prem. So you'll see here this AWS DC2. So I'll pop in here to DC2. And this looks just like all the other machines. This is, when we say single pane, this is single pane of glass, right? So there is absolutely no difference. The only reason you know that this machine is in AWS is because it's been named AWS, or you may know the IP range, right? You may know that this is the IP address. The IP addresses are durable across DHCP because we're picking up the wire data. So just because a machine changes its IP address doesn't make it a different machine. So we'll keep all of that history, bound to the IP address and the name resolution for that machine. So here inside of AWS, we're able to pick up this machine. We have virtual sensors that can be deployed into AWS. So this is an EC2 instance, and we're seeing the same things here, right? We're seeing that same hidden HTTPS tunnel. We're seeing file share enumeration here. So somebody's gotten on a domain controller. And just from the wire data, I can see the accounts that are doing and the file shares that are being enumerated. So I can see the accounts and the enumeration happening here on my AWS server. I can see, again, more targeted RPC reconnaissance. Port sweeps are going on here. Another, we talked about tunnel. Here's an exfiltration. And then a privileged anomaly unusual service. So in this particular case, we're able to pick up, well, actually not in this case, but for all systems, we're able to pick up privileged anomalies from unusual accounts and from unusual services and what we call a trio, which is kind of the trifecta, right? So here's an account that traditionally does use this machine, but a service that both this user and this machine don't see. This is the type of thing that we'll see oftentimes on a ransomware attack from a local encryption. So these are the types of things that very much set off these very high threat uncertainties for us. And the other thing is we have inside of our system the ability to understand what each of these detections are with these question marks. So these question marks will walk you through any particular vulnerability that you're looking at. So you can click on that in real time. This is everywhere. We have one for each and every one of our detections. If you want to understand our scoring, how the host scoring is done, as well as the detection scoring, and understanding the singular detection and the host scoring are independent. The host is for the host against the environment as a whole. The detection is against the singular detection against the environment as a whole. And again, those are all machine learning generated. So that's kind of the host side. Then we have the account side. And when we take a look at the accounts, we can be looking at corporate accounts, or we can be looking at O365 accounts, or we can be looking at both, where we were showing a little bit earlier. So here I'll pick a O365 account. Actually, this is a dual, right? So this account is a combination of a Prem account and an Azure AD account. We use our machine learning to bind the two accounts together, even though they exist in separate Active Directories. They're very much separate accounts. We're the only product on the market today that is connecting the Azure AD account and the Prem AD account. And then from the Prem AD account, we're also able to stitch in the host so that we're able to look at these detections, not just in O365, but down to the on-prem user, down on the on-prem host. And in this particular instance, you'll see things like this unusual e-discovery going on. And this is a search that was created to search for anything that had the word patent or source in it. And again, we're using this attack phase, right? Command and control, reconnaissance, lateral. And from there, we're also able to see that there was suspicious Azure AD operations, changing federations settings in the domain. So, and then we're also seeing exfiltration with exchange transport rules. But again, we talked about having that to the Prem. So here's a lateral movement we see with privileged anomaly unusual trio on this user. And we're able to see a user that doesn't log into a machine, service that doesn't run on the machine, a service that doesn't get run by the user. And remember, we started in this as an account. So we're looking at 365 detections. This is very much an on-prem user with an on-prem detection. And I'll step through this a little bit more as to what this actually is that we're looking at. But I do think maybe if we've got a couple questions in the queue, we could address them before I just kind of run right through a monolithic speech here.
Hey, Jeff, there was one question about Google Spider activity. I believe, I asked for clarification on the context behind that, but I believe it's whether or not we see that type of activity as malicious. Correct me if I'm misinterpreting the question, but I believe that's what he's asking.
Right. So we do not have specifically anything. So I'm not 100% on that particular as well. So I'm going to be clear, however, on some of these things, and it might answer the question as well. We are working on infrastructure-based next-gen components right now that will watch native infrastructures. Right now, we are watching O365 as an application network. We are watching VMs in Azure. We are watching EC2 instances in AWS, and we are watching wire data on AWS, on Azure, and on-prem. So regardless of where the attack comes from, unless it is an infrastructure level attack or an attack on GCP as a suite, which are currently not in our portfolio today. So we do not have a GCP suite protection tool like we have for O365. We're also not watching GCP infra at this time. We are adding as quickly as possible infrastructure for things like AWS and Azure, and then onto GCP. But regardless of the tooling that's being used, if it's an attack against any of the infrastructures we're seeing, we're going to see the behaviors as opposed to the tools themselves. So whether you've custom written a tool in your garage that starts off by getting some type of command and control, and then from there does some level of reconnaissance into the network, we will pick that up on the wire at some point while it's happening, even if it's been completely written from scratch.
Yeah, so Jeff, I would like to add that GCP is coming. It's on our roadmap, yes. So that's an exciting add-on for us. But also, I would like to highlight one point that in terms of how we view certain types of traffic or behaviors with the Vectra platform, you do have the ability to triage out certain activities. That's extremely important because what we see a lot in today's world is that, you know, people claim, hey, AI is going to solve every problem in the world, right? That is just simply not the case. I can't take one business in one vertical and say with 100% certainty that normal behavior at that particular location is going to be the same as another business in a completely different vertical, right? So you have to be able to have that supervised and unsupervised algorithms like Vectra has to be able to put that human touch on the triage process so you can keep the sword sharp over time, if that makes sense. Jeff, it looks like there was another question around the O365e Discovery attack as well. Okay. Maybe explaining a little bit more detail around that.
Okay. So what we do this, gonna kind of pop over. We're gonna actually pop over into because we were kind of exploring how and showing how we work on things like the SolarWinds breach, but it has the e-discovery component in it. So I'll do it through here. All right. Don't kill me for ambulance chasing, guys. This is not what this is intended to be. This just kind of shows where rubber meets the road, and this style of attack and these vectors have been utilized for quite some time and are now becoming extremely popular. And so showing how we detect and respond to something like this is very much take the pieces that are valuable. I know that the SolarWinds thing is over, but is it really is a whole nother question. But that style is now something that we're seeing repetitively, and so it's important, I think, to understand how we differentiate there, and I think it also shows how the product operates. So I'll take you through this. You guys probably have all seen and been through this, right? So SolarWinds, first we had the supply chain compromise, then the machine dialed back, set up a tunnel for itself. That looked totally normal because the machine has a number of tunnels that it uses for dial home. Then we saw internal domain reconnaissance, figuring out which users had admin access. And then from there, it went on to get that domain access because it was able to use the access of the SolarWinds box to do that. From there, it did SAML cert signing and forging of SAML. Then it went on and modified the federations. And then it did admin access for the Azure AD. as part of it, and that was just persistent at that point. And so we saw the OAuth modification and then exfiltration however they felt like it, right? Whatever tooling they felt like doing, they did. And so to the Vectra solution, and I know this is an eye chart, but what it really looked like was we saw the command and control set up. We saw the hidden tunnels go up. At that point, someone, even myself, would most likely have what we call triaged the tunnel. We would have said that tunnel is totally normal. Then from there, we saw the suspicious LDAP queries in the RPC reconnaissance. For most Vectra customers, that's where they put a bullet in this attack. Vectra is unaware of any customer that had this in an environment that was compromised. That's the statement that we make. From there, we saw the lateral movement with the suspicious remote executions, and then on and into O365. And in the O365, and I'm just going to blow it up so it's a little easier to read, we saw the admin access into Azure AD, and then we saw the modification of the federations and the modification of OAuth, and then the exfiltration. And so when we talk about, what is the e-discovery stuff and how does that work, right? That was very much part of it. I see a hand raise. So Britt, if you've got a question for him, please just shout it out.
Sure. Yeah. Keep going on that one. And I don't know if you have more about that, but one thing I wanted to add too is, you go through the profile of something like a supply chain attack. You've got to pay close attention to, back to my comment earlier about detections that matter. The last thing that you want to be is overwhelmed by, thousands of anomalies that are coming through the system, right? And that's what Jeff is describing through our platform, right? We pride ourselves in the ability to focus on what matters, and again, giving you the ability to triage that out so that you're not overwhelmed in the SOC. So very important concept.
So here you'll see this is the host tab, right? So this is the Orion server. So what we have done is, and I showed you one down here with a thread feed that was at low. We have specifically removed anything in a thread feed having to do with the attack, so that it doesn't affect the metrics. You can see how our customers saw the attack. So this is a fully played out. Our customers didn't let it get this far, but this is what it would look like. We have the Orion server. We had the command and control, right? So this is a hidden HTTPS tunnel. I kind of showed you how that worked a little earlier. But the truth about the hidden tunnel is that what we really would have done with this hidden tunnel as an operator is we would have triaged this, and I'll show you how easy that is to do. We can come in here and just create a custom filter and poof, mark it as valid. I'm not going to do that right now because other people use this environment, but it's that easy. And that's what a SOC operator would have done when they saw the Orion server dial back. They would have assumed this is dial home functionality. I personally would have assumed this is dial home functionality. The next thing we saw, and I show this to you up here, not just in this big fun graph, but also in the graphic, right? So here's where we are. We are at number 4, and then we move on. Number 5 is done. The tunnel is established. We still mark this okay. Number 6 is the domain reconnaissance. So what we saw here was reconnaissance, both some RPC reconnaissance, which is pretty unusual for this particular machine, but we also saw the suspicious LDAP query go out. So we saw this LDAP query, and what was the LDAP query? Show me all groups that have more than 1 or more admins in them, and then show me all the users in those groups. And all of a sudden, I have 67 administrator accounts via a single LDAP query. So now my Orion server has relayed 67 admin accounts back onto itself. Here we've got a hidden tunnel to the machine. You can figure out what that means. And I was able to execute a suspicious LDAP query, which means I got the response. And now I have a list of 67 admin accounts. So from this point, this is where our customers basically said, this is something that's going on. We need to look at it and be serious about it. And then from there, we saw suspicious remote execution, which is against the target here. We saw, what did they do? Suspicious remote execution, task scheduler. So we saw a registry task go out on this machine. And then from there, we saw privileged anomaly unusual trio. And I'll pop into this. So this is the privileged anomaly unusual trio. And this is the user, the machine, and the service. Nothing here lines up. And this is the account that they're using. And so we see this account here. So when we go into the account, this calls right back to what I was showing you a little earlier, which is that this account, not just the prem detections, which we picked up because the Orion server was compromised, but we can see that they have lateraled into using this account into O365. And what have they done when they got there? The first things they did was command and control. So this is a suspicious PowerFlow automate. So what do? They set up through PowerFlow a creation of a flow that uses Dropbox and SharePoint. So this is a recurring task that is going to pull things out of SharePoint and put them into Dropbox, or potentially pull commands out of Dropbox and execute them. We saw another command and control, redundant Azure AD access creation. So here we're seeing email archiving, adding principals, right? So we've got added credentials. And then on command and control, we have more suspicious Azure sign in. So this one's pretty straightforward. This is just a rare IP address. So again, this is something that could just be noise in and of itself, right? A suspicious IP address is not something that anybody should be spending their time looking at in isolation, right? So from command and control, we see the reconnaissance begin. There is the unusual e-discovery. So let's pop this open. So this is an e-discovery. E-discovery is a tool offered by Microsoft as part of the O365 suite. It is meant for compliance purposes and allows people to search for whatever they have permissions to, regardless of what it is. So I can search SharePoint entries and Excel documents and Word documents all at the same time for any particular string that I would like. And in this particular case, we can see that this is the query that they have put together. So what are they looking for? They are looking for, they've named this search, do not touch, compliance search, description, do not touch. So if you're a regular admin and you look at this, this is what you're going to see from name and description, probably enough to keep most people from remediating their own environment. And then what they're looking at is, show me all the Exchange operations, all locations, SharePoint locations, Exchange locations, and what am I looking for? Source or code or patent. And if it finds any of these things, it is then going to work hand in hand with that Power Automate script that we've seen to exfiltrate this. We'll come back to this account. And so that's the unusual e-discovery we see here in reconnaissance. We'll see the lateral movements next, right? So suspicious Azure AD operation. So in this particular case, modification of the federation settings on the domain. So now I've federated with a third-party domain. That'll bypass any MFA you'll ever put in place. And then we see more lateral activity. This is that trio action that we saw. And then we see the exfiltration, right? The exfiltration here in this particular case is an Exchange transport, but this could be anything. This could be another Power Automate that sends Twitter DMs. This could be, as we saw, the Dropbox saving. And so we'll see this, and this is just a new Exchange transport rule. So again, each and every one of these is pretty much benign by itself, except maybe the federating. But what we have here is the ability to visualize this using the AI, and we've pulled this out among, in an environment with thousands of users, you have tens to hundreds of thousands of log entries per day to go through. And so we've pulled these out and we've associated them accordingly. And to do this, we just use read access to the Azure AD logs and to the O365 application logs. And so that's the part of this, not part of this, but this is a big part of why we've been working very tightly with Microsoft. And Microsoft has done a joint marketing component with us, but a joint operation in a better together. So if you pop over to Microsoft's page, you'll find us on their site talking about how Vectra is really a big part of the better together in the NDR story and fills that that void that is very much needed.
Hey, Jeff, one question popped up here about how Vectra collects all the IP addresses of an organization as the algorithms do their work. Maybe you could address that briefly.
Sure. All right. So when we look at the environment, and so I'll pop onto the dashboard here, and then I'll pivot a little bit and talk about that. So what we have here for all of these hosts, and I'm just going to go back and pick out. Actually, I can pick out just about any one of them, but Piper Desktop is the one we started with, so I'll stay on the machine. So when I go to Piper Desktop, what I've got is this details tab here that I'm seeing, and so this details tab is going to show me a few different things. So I've got a number of different ways that I've been able to enhance with the wire data artifacts. So here I've got DHCP capabilities. I've got Kerberos, which is not been detected here, but Kerberos capabilities. We do have APIs that work with vCenter, CrowdStrike, ATP. They enhance the artifacts. They are not mandatory for operation. But what we are looking to have, and you can kind of see it here, all of these different ways and methods are how we know the name of this machine, and this machine is this machine. And so what we're doing is we are pulling the name out of these different methods, but the IP address last seen is very much changing over time, right? So I might take my machine home, and when it's on VPN, it has one IP address, and then I bring it to Starbucks and it has another one, and then I bring it into the office and it has another one. We're aware that those pools are in constant reuse. So for wire data purposes, we are pulling the IP address as seen, and then we are using our integrations or potentially wire data. So DHCP data is wire data, we'll pick that up. Kerberos is unencrypted wire data, we'll pick that up. LDAP is unencrypted wire data, we'll pick that up. And TLM is unencrypted, we'll pick that up. But we'll also get enhanced resolution from integrations like vCenter. So for example, through the vCenter integration, I am aware that this is a Microsoft Windows 10 machine, right? So it's going to give me a little more. And I know that it's a VM because vCenter is telling me about it. So this is where we're able to get a little more resolution on it. But without these, we still have all the DHCP data, all the NTLM data, all the Kerberos data. And so we are looking to see the data in flight by the IP addresses, and then we are looking to bind. When we have services like Zscaler, for example, where we're natting to the Zscaler address, we have a ZPA plugin that we work via API with Zscaler to reverse out the originating host. So we're able to, even through those NAT translations with the Zscaler, find the originator. Hopefully that answers that.
Okay, then there's one that came up. I'll just read it verbatim for you. Can it bypass Azure security like network security groups, making VMs on private and using firewall along with MFA and RBAC roles properly?
Okay, so is that in the chat?
Yeah, it sure is.
Give me a second to.
Yeah, no worries.
I'm not seeing that one. Can you read that one again?
Yeah, I can break it up slowly for you. That's okay.
Okay. Yeah.
Can Vectra bypass Azure security like network security groups?
So I mean, how we look at Azure is, first of all, we are looking at Azure AD. So we do have that with the O365. So we are able to see the users, and we are able to see everything going on within Azure AD. As far as the prem side, the NDR side, if you're using it for something other than O365, we have the virtual sensors we can deploy. Or if you're using it within 365, we will pick up how those accounts are being used within 365, again, based on that API integration, or we call it API, but it's a custom application with read access to the O365 and the Azure AD logs.
Yeah, and so Mil, just to give you a little bit more detail around that, that's probably, I'd say in the past couple months, one of our most requested features or deployments, putting those virtual sensors into an Azure environment. I keep encountering those more and more with both prospects and clients. So it's definitely, you know, a popular item across the board. Did that answer your question? Looks like it may have. Okay.
Yeah.
Oh, we got another hand.
And then I'll answer there's one from Sebastian. Generally benign events with the exception of federation under lateral movement. So we have the threat scores. So one of the important things, and this is something I should clarify, when we take a look at the system, we have these threat scores. We have a detection score, which is the individualized detection as we're seeing it. And so we're scoring that. But it's really this host scoring that matters. This is what puts it on the map, and this is what kind of puts it in the SOC operator's hands, if you will, because the host scoring, and the host scoring is not necessarily a strict addition problem to the score. So I've got a machine here with 2 tunnels. I got a machine here with 5 tunnels, right? It's really this progression. There's some time decay components to it. And, you know, here we've got some scores here where I got 40 and 80 on the detection, but the host in and of itself is still very low, right? So we have these detection scores and we have these host scores, and you really need the machine learning really needs to take a look at a few different things beyond just what these individualized detections represent. All right, those hand raises, what do we got?
Let's see. Reviewing the current list. I don't see any more coming through. Any more questions from the crowd? I believe that's it.
All right.
Well, thank you to everyone for attending the session.